Hello, ladies and gentlemen. Welcome back to trigonometry. We're looking at Unit 3, Lesson 3, talking about graphing cosecant and secant. So what you want to remember is that cosecant is 1 over sine and secant is 1 over cosine. Remember that simple idea that there's one co between each pair. So we want you to be able to graph cosecant and secant and graph any transformations. Now, good news first, we're not going to get too crazy with the transformations. I'm more interested in, can you sketch a simple graph of what cosecant and secant is. So if you look, you remember cosecant is just 1 over sine, secant is 1 over cosine. So that, don't worry about this. I don't know, that was a bad joke somebody else wrote. So all you're doing is taking whatever sine is and put 1 over it. And for secant, you're taking whatever cosine is and putting 1 over it. Okay, so we're going to look at what we're trying to deal with here. So this right here would be a basic sine function. All right, so starting at negative pi, you go up, pi, 0, zeros, you go up to 1, down to negative 1. This is your simple pi function, okay? So if I just go along, at 0, I'm at 0. At pi, I'm at 0. At 2 pi, I'm at 0. Pi over 2, I'm at 1. 3 pi over 2, I'm at negative 1. If you want to put in radian mode, sine of pi over 4, it'd be 0.707 as a decimal if you really wanted to put that. Otherwise known as square root of 2 over 2. And these are negative, square root of 2 over 2. Okay? So 0.707, or looking at your unit circle, or doing a quick sketch will tell you that those are square root of 2 over 2. So now cosecant says take whatever that is and put 1 over it. So that'd be 1 over 0, 1 over square root of 2 over 2, 1 over 1. Once again, 1 over square root of 2 over 2, 1 over 0, 1 over negative square root of 2 over 2, 1 over negative 1, again, 1 over negative square root of 2 over 2, and 1 over 0. So now, if you notice, we have a couple of 1 over 0 situations. All right, so this is 1, this is going to be negative 1. Some of the other ones, you could simplify it if you really wanted to, but that's neither here nor there. You guys have done that before. 1 over 0 is a problem. 1 over 0, we can't do that in math, right? So 1 over 0, that's one of those things that we call undefined. Okay, you probably heard that term before. It's trying to do a mathematical operation that's impossible. And dividing by 0 is, one of those things that's mathematically impossible. Okay, so how do we show that graphically? So on the graph, all that happens is this. Wherever we have that 1 over 0, we draw what's called an asymptote. So we draw a vertical line where all of these are. Okay? So we're going to draw a vertical line every place that there is 0. Okay? So now, when you go to graph the cosecant of x, here's kind of all that I do. So wherever this is 1, then that's going to be 1 as well. And I end up just reflecting. So this one, so if you see this graph goes down, I'm going to reflect it so it goes up like that. Likewise down here, I'm at negative 1. See, the graph goes this way, so I'm going to reflect it this way. So here, the graph goes like this, so I'm just going to reflect it back the other way. So now the arrows signify that the graph is going to keep going towards these asymptotes, but they're never going to cross. So my final sketch is going to look like that. So my period, how long is it going to take to do one of these? Well, I have to count 1 up and 1 down as my period. So my period is still going to be 2 pi. So now now what's my domain? So my domain is every x value, but I have a couple x values that don't work. I have, 0 doesn't work, pi doesn't work, 2 pi doesn't work. If I go negative, that's negative pi, that one doesn't work. Negative 2 pi, that one doesn't work. So what I can say is x cannot equal any integer times pi. So I can say any number times pi is not going to work. Any number times pi is going to give me a asymptote, and that's not going to work. Okay, so what's my range? How far can I go up or down? Well, my graphs go up forever, and then they bottom out at 1. Okay, and from here, I'm coming from negative infinity to negative 1, then back out to negative infinity. So it's going to come from negative infinity to negative 1, and then it's also going to include 1 out to infinity. And if you're a little turned around by the using symbols here, all that means is that including negative infinity, including negative 1, including 1 going out to infinity, and that's just the old union symbol, meaning that I'm going to do both of those. Okay, but the big picture here is this. Can you see how I used the original sine function, and just every time I hit a pi, 1 pi, 2 pi, 0 pi, negative 1 pi, that became my asymptote. Basically, anytime I crossed my x-axis or my midline, that became an asymptote. Okay, so I know it's really hard to do this all at once, but it's not bad if you break it into piece by piece. Okay, so if I look at cosine, that's the graph I have. So at 0, I'm at 1. Let me pick a different color here. So that's going to be square root of 2 over 2. That's going to be 0, negative square root of 2 over 2. So that's going to be negative 1, negative square root of 2 over 2, 0, square root of 2 over 2, and 1. So now remember, it's 1 over all of these things. So that's 1. So that's going to be 1 over square root of 2 over 2, which flipped all the way around kind of gives you square root of 2. So this is going to be another undefined. So it's going to be negative square root of 2. That's going to be negative 1. Negative square root of 2 when it's simplified, another undefined. Square root of 2 and then 1. So now when I look kind of at my graph, anytime I cross my midline, anytime I cross, in this case, the x-axis, that's where I want to draw my asymptote, all right? I'm never going to be able to cross that line, all right? So then when I go to sketch this, I want to just reflect those. It's going to look like that. Okay, so I'm taking my cosine graph. This is my cosine graph right here. All right, the blue one. I'm doing that, and then I'm just basically flipping it out and drawing wherever it crosses the x-axis to be a 0. So again, just like before, 2 pi, because I have to go 1 full up and 1 full down. Domain here looks a little bit different because I'm going every pi over 2 plus 1. So x cannot equal pi over 2 plus some number times pi. The way I would write it is that. So n is going to be an integer. So that's going to be every pi over 2 or every half pi. Now my range is the same. I come from negative infinity to negative 1 and from 1 out to infinity. Okay, so that kind of gives me a basic idea. So if I want to now graph anything where I have to move it, any kind of translation or transformation, I'm going to graph my original function and then sketch it from there. So I'll sketch my vertical asymptotes, then I'll sketch my graph, and then kind of go from there. So if I took 3 secant x, I'm going to compare that to 3 cosine of x. All right? So period is going to be the same, 2 pi. Reflection over the x-axis, no. Okay, 3 is not negative. Vertical shift, no. It's going to be a vertical stretch by a factor of 3. All right. So I'm going to graph 3 cosine of x. All right, so cosine starts there, go to 0, negative 3, back up to 0. It's going to look kind of like that. So that would be cosine of x. So then when I go to graph secant, I'm going to draw my asymptotes. And then I'm just going to sketch my U shapes going away from that. So it's going to look kind of like that. All right, so take a second, just kind of look at what I did, and then see if you have questions. Okay, so negative cosecant. So cosecant is kind of like going the sine of x, right? So my period's still going to be 2 pi. I'm not moving anything. Reflection over the x-axis, yes, because there's a negative out front. No vertical shift, no shift or shrink, so nothing there. So all I'm going to do is basically draw the sine function, but flipped over. Okay, so if I just draw the sine of x negative, that starts at 0, and then that's going to come down to, we'll go 2 blocks here, negative 1. So it's going to look like that. So down, up, and back. So this one's going to go back like that. So that would be the negative sine function. And now all I do to change it is wherever I cross the x-axis, I draw an asymptote. So then I just kind of draw my u's going away. So I go here and here. I go here and here. And then I go here and here. All right, that's kind of all I'm looking for. I'm not trying to break your brain or anything. I'm just trying to get you to realize that when I flip that over, that's what it looks like. All right, so secant of x, but I put a negative 3 out there. So that's still going to be 2 pi. No reflection, even though it's minus. It's not a minus in front. Vertical shift, yes. I'm going to take this whole thing and move it down 3 with no vertical stretch or shrink. Okay, so it's secant, so I want cosine. All right, so what I'm going to do is instead of at 0, this becomes my new midline right down here. All right, so if I sketch cosine, instead of starting up at 1, I'm starting here. So I'm going like this. So that would be my cosine function moved down 3. And then going backwards, it's just going to be kind of a mirror of that. Okay, so now, instead of just every time I cross my x-axis, anytime I cross the midline, that becomes an asymptote. So then when I go to graph, it looks like this. And that's going to be your final product. Okay, so what's going to happen here? Well, cosecant, meaning I want sine of x. Period's still going to be 2 pi. Reflection, yes, because there's a negative out front. Vertical shift, no. Vertical shrink, and it's going to shrink by a half. So what's my sine function going to look like then? Well, if I count that as 1 and that as -1, that means I'm only going to go up and down to half of that. So I'm going down to half, back up to 0, up to half, back down to there, and then reflect that on the other side. Okay, so I'm only going up to a half or down to -1/2. So then, what does cosecant look like? Well, draw your asymptotes, and then kind of sketch your U-shapes from there. Like that. Okay, that's what you're looking at. Last one, this does a couple things. Secant, or cosecant means I want sine of x. Period, 2 pi. Reflection, yep, because it's a -2 in front. I'm going to move the whole thing up 1, and it's going to be a vertical stretch by 2. So that means I'm moving the whole thing up 1. So this becomes my new midline. Okay, it's a sine function, but it's a stretch of 2. So from 0, and it's a reflection. So I'm going to go down 2, back to 0, up 2, back to 0. And I'm going to do the same thing here. Okay, so up 2, down 2, but I move the whole thing up 1. So then you're drawing your asymptotes, and then you're sketching up and down for what your graph looks like. Okay, that's what you're kind of playing around with. That's what I'm asking you to do. I'm not asking you to shift anything right now or get anything complicated. So that's kind of what you're looking at for there. And you should be able to do the whole assignment. Okay, let me know if you got questions, and we will talk to you soon.